Hello, this is Rorschach from Lumatic Devices, and it's ace. Rorschach is a lo-fi video synthesizer, and I'm really enjoying using it. This is not a review video. What it is that I use Rorschach with primarily modular synthesis, and normally that is Eurorack, and Eurorack modulation has a different voltage to Rorschach. That is to say that Eurorack uses plus or minus 5 volts unattenuated, and Rorschach, being a digital to analog video synthesizer, will only accept modulation in the range 0 to 5 volts. So for the CV inputs at the top here, if you just input an unattenuated Eurorack signal, you will not get the proper return for the waveform that you put in. And in this video, we're going to discuss the problem. We're going to design a circuit that allows me to completely change the Eurorack signal that's coming in so that it is fully acceptable by Rorschach and covers its full 0 to 5 volt range. Okay, so let's have a look at the problem. On this graph we have volts, plus and minus, and we have time. And this line here, going from minus 5 to plus 5 volts, is a normal Eurorack signal. So for example, a low frequency oscillator. The red line from 0 to 5 is the band in which Rorschach will accept its input CV voltage. So if we were to just put a normal LFO into Rorschach, for the periods where the waveform is below 0, Rorschach will effectively just be stuck at its lowest voltage, that is to say 0. So from a triangle input, we would have an attenuated triangle where for at least half the waveform, Rorschach is just stuck at 0 volts. So if you were using this as a CV input to, let's say, the horizontal position on Rorschach, it would start at the bottom, and it would just stay at the bottom, and it would go up, down, and then a long period again when it was at the bottom, and it would just repeat. So whilst you are using the full range of Rorschach, for a large portion of it, it would be stuck on just one value. So what we need to do is we need to design a circuit that takes this minus 5 to plus 5, and first of all, it attenuates that so it's just between 0 and 5. We also then need to offset the attenuated triangle so that it is centered at 2.5 volts, so that we get the full triangle waveform between the values of 0 and 5, so Rorschach can use that voltage across its full range without any dead spots. Okay, I hear you say, what about unipolar LFOs in Eurorack? Well, they would again go from 0 to 10 across the full 10 range, with the lowest value at 0. But we have the same problem here in that when it's above 5 volts, Rorschach is just pinned at its top value. So we have this green line now where it goes up, sits at its top value, down, up, sits at its top value. So again, it's the same problem with unipolar LFOs. Now I know that in Eurorack you can use different modules to attenuate and put offset voltages. You know, I can do that, no problem, but for my purposes, I just want a simple box where I plug in an LFO and out comes a 0 to 5 volts attenuated and centered signal, which can then be used at within Rorschach without any messing about through other modules or attenuation or offsetting. So what are the requirements then? Okay, so first of all, we've got to attenuate Eurorack signal from plus or minus 5 to 5 volts peak to peak. We've got to offset that so that it outputs at only 0 to 5 volts, which can be fully used by Rorschach. I also just want to use a single 12 volt DC power supply. This is going to be a standalone unit, so that if I'm not using a big Eurorack system, I'm just using other standalone synthesizers, I can still use it with Rorschach. And I would like up to 4 channels so that I can make full use of the CV inputs. So let's have a look at what we might be able to do. Okay, so let's look at one of the first of those problems, which is attenuating from the 10 volts peak to peak that Eurorack uses down to 0 to 5 volts. And we're going to use a simple op-amp circuit for this. So here is our op-amp with a negative and a positive input and our output. And our signal will come in and go into the negative input, and then we will use feedback from the output back into the negative input, and we will put 2 resistors that we will select so that we get half of the output as to the input. And for that we could use, for example, something like a 4.7k resistor and a 10k resistor on the input, and the ratio of those 2 resistors will give us 0 to 10 volts, or sorry, yes, 0 to 10 volts peak to peak on the input, but that will give us a 0 to 5 volts on the output. Okay, so far so good, and the positive is tied to ground in this instance. So now let's think about how we're going to put an offset in. Well, what we'll do is we'll sum the offset voltage into this op-amp so that we then have some control over it. So we'll take another input, we'll use the same resistance so that we get the same ratio of attenuation through the op-amp, so we haven't got to mess about matching things. And now what we're going to do is we're going to put a variable resistor in. We're going to tie it to negative 12 volts and ground, and then by using the attenuator we can match the voltage so that it rises at the negative input to center the output at 2.5 volts. I'm going to do one more thing as well, which is that it occurs to me that it would be useful for us to be able to put a through port on the input so that we can take an LFO into this circuit, and then we can take the signal unattenuated or unchanged back out again. So we could use it for, let's say, a filter as well as feeding Rorschach with its modified value. So all we're going to do is tie another jack socket as a through. Now the last thing we need to think about is power, and we do need plus 12 volts and minus 12 volts. Now if this was in a Eurorack format, that would be fine. We just take the power from the Eurorack power supply, from the case power supply. But we don't have that. I don't want to use just a single 12 volt DC power supply. So we're going to use an all-in-one power supply chip, and it's called an RB1212. And with this, what we do is we put in our plus 12 and the ground from our input, and then the chip magically provides us minus 12, the ground, which we will use for the ground on the circuit, and a plus 12. It's a great little chip. Here it is here. And for the amount of power that we require for this circuit, I think this is good for up to 1 amp. So we're going to be down in the hundreds of milliamps, I imagine, when this is all said and done. So this should be a great solution for us. Means we haven't got to bother designing a bespoke power supply to give us a -12. And I think this will be great for the job. As for the op amp, well, if we want 4 channels, then I think what we're going to use is probably something like a TL074 or equivalent, and we can then use this circuit but make it quadruple it, and then we can use all of the 4 op amps in our chip. Okay. Oh, there you go, you can actually see it now. Perfect. So I'm going to throw all that together on a breadboard, and let's see whether or not the theory matches the practice. Okay, so I've put that circuit together on the breadboard, and I'm just using my Rorschach 852 Pro to put in a triangle wave at -5 to +5 volts. That's shown in blue, and that's there just to simulate the Eurorack output from, let's say, an LFO. So I'm powering the circuit at the moment just from a power supply, 12 volts DC, and we're drawing 0.024 of an amp. So, as I say, low power, and we are actually using the little all-in-one power supply chip to provide the voltages onto the circuit. So I think that'll be absolutely fine. So let's have a look now at the output, and it's in on the yellow trace there, and we can see that we are attenuating it to just over a half, so that's fine. That's a peak-to-peak voltage of about 4.7 volts. So that's grand. So let's now have a look at whether or not we can offset. So this is my little offset potentiometer, so I'm just going to start to introduce some negative voltage into the summing amp, and as you can see, we are moving the yellow trace up, and now it is sitting squarely within the 0 to 5 volts positive that Rorschach will accept. So yeah, I think that works really very nicely. So now I need to find a little case. I need to sort out how I'm going to construct it, put the circuit together, and then we'll have a look and see how we get on. Good. Okay, we're back. I put together the circuit. I use these little solderable PCBs here. I just find them very useful for this sort of project. There's 2 layers here. The first layer has all the ins and outs on mini jacks, and then the bottom layer has the power supply, just running off that 12 volt DC, and also the op amp and the associated circuitry. So I've got Rorschach up and running now. Let's put an unattenuated and signal in. So this is what it would look like just with a normal Eurorack modulation signal going in. You can see that the system hangs at the top where that waveform is now above that 5 volts or below the 0 volts that Rorschach can tolerate. So we're not using the full range of the Eurorack, in this case LFO. Let's put a attenuated and offset one in. So this is now running through the circuit, and see what the difference is. and you can see now that we have full range. So we're using all of that plus, well, that 0 to 5 volts. Let's mirror those up, and let's put a bit more modulation in then, just so that we can see how we can actually use the full range now without any of that hang time. And we'll put some into form as well. So yeah, I'm very pleased with that. That seems to be working very well. So the only thing that remains now is for me to use this little Hammond project box here, and we'll drill a hole through for the ins and outs on the top, a power port on the back, and that then will be ready to go. So yeah, that's a good little project. I hope you found that useful, and I will take some video of it being used in the future so that you can admire Rorschach in all its glory. Thanks for watching.